Hi, this is Wendy Lightheart, and today we're going to look at how to factor trinomials that have a leading coefficient of 1. So in order to factor trinomials that have a leading coefficient of 1, we need to go back to FOIL, because really we're just going the opposite direction. We're going to be factoring trinomials like the trinomial x squared plus 7x plus 10, and we want our answer to be the factors of that trinomial, which in this case would be x plus 2 times x plus 5. So in order to figure out how to go backwards into the factored form, it's important to know how FOIL works. So if we go back and remember that the x squared comes from the x times the x, so the first term in each set of parentheses gives us the first term of our trinomial. So we know that if we're going to factor this trinomial, if the first term is x squared, then the first term of each set of parentheses need to be both x. And then notice that the 7 comes from the 2 and the 5 that are in the parentheses with the x's. When we add those together, that gives us the middle coefficient of 7. And when we multiply the last terms, which is the 2 and the 5 again, we get the last term of 10. So two numbers multiply to give us the last term of 10, and those same two numbers will add to the middle coefficient of 7. And that's going to be the case for every trinomial whose leading coefficient is 1. If it factors, then there has to be two numbers that multiply to give you the constant on the end that also add to give you the middle coefficient. So that's what we're going to use to factor these trinomials. So here's our strategy for factoring trinomials of the form x squared plus bx plus c. So the first step is, since we know that in order to get x squared as our first term, we need to have an x in the front in both sets of parentheses. So we go ahead and write the two sets of parentheses and place our x's. Then our next step is, since we know that the two numbers that go inside the parentheses with the x's need to multiply to give us the constant on the end, then we list pairs of factors of that constant. And we're going to organize this information in a table. So we'll list the factors of the constant c on the left side of the table. And then on the right side of the table, we're going to find the sum of each of those pairs of factors. And remember that we're looking for two numbers that multiply to give us the c, and they add to give us the middle coefficient of b. So once we find the sum of b, we can stop listing our pairs of factors in our table. And those are the two numbers we're going to use to finish our factoring. So once we find those two numbers, we insert those pairs of factors into the parentheses with the x's, and then we can always check our answer using FOIL. So here's our first example, x squared plus 5x plus 6. We want to find two binomial factors that if we were to FOIL them out, we would get that trinomial back. So we know that the first term in each set of parentheses need to be x, so that's our first step, is to write our two sets of parentheses and place x's in the front of each set. Then our second step is to list factors of the constant, which in this case is 6. So factors of 6, we could multiply 1 times 6 to get 6. We could also multiply 2 times 3 to get 6. Note that I'm not including negative factors like -1 and -6, because even though -1 times -6 would also multiply to give me +6, the sum of those numbers would be negative, and I'm looking for a positive sum because I'm looking for a sum of +5, which is the middle coefficient. So if you think about the signs ahead of time, that can help reduce the number of possibilities that you're listing in your table. So then we list the sums on the right side of the table. So if we add the 1 and the 6 together, we get 7, and that's not the sum we're looking for. So we keep going and add the 2 and the 3 together, and we get 5, which is the sum that we're looking for. So the 2 and the 3 are the numbers that we need, and what we do with them is we place them in the parentheses with the x's. And the order doesn't really matter. I could have put the 3 in the first set and the 2 in the second set. It doesn't matter. So then after I place those numbers inside the parentheses, I can always check my answer using FOIL to make sure I factored it properly. And as you can see, when you FOIL this out, it does give you x squared plus 5x plus 6, which is the trinomial we were factoring. So our answer for this problem is x plus 2 times x plus 3. Here's another example where the leading coefficient is 1 again. So our first step is to write 2 sets of parentheses and place x's in the front of each set. Then we're going to list factors of the constant, which in this case is negative 18. Now if you think about the signs, in order to multiply to give you a negative number, you're going to need a positive factor and a negative factor. So 1 times negative 18 would equal negative 18. 2 times negative 9 would also give me negative 18, and so on. Note that I'm not including factors like negative 2 and positive 9, because even though those will multiply to negative 18 as well, if you add them together, notice you would get a positive sum, and we're looking for a negative sum because the sum we're looking for is the middle coefficient on our trinomial, which is negative 3. So I need to make sure that in my pair of factors that I make the bigger number the negative one, so that when I add them together I get a negative sum. So let's look at what those sums look like. So I list the sums on the right side of my table. First I try 1 plus negative 18. That adds to negative 17. That's not the sum I'm looking for. 2 plus negative 9 is negative 7. That's also not the sum I'm looking for. But when I add the 3 and the negative 6, I get negative 3, and that is the sum I'm looking for. So I know that I have found the numbers I need, and what I do with those numbers is I place them inside the parentheses with the x's. So this trinomial factors into x plus 3 times x minus 6. And you can see here that when we check using FOIL, we can see that we did get the right answer. Here's another example, x squared minus 5x minus 12. The leading coefficient is 1 again, so I know that I'm going to need an x in the front of each set of parentheses, so I go ahead and write that first. Then I'm going to list factors of the constant, which in this case is negative 12. And I would need them to add to a negative sum, so again I'm only going to list factors where the signs need to be opposite, but the negative needs to go on the bigger number, so that guarantees the sums will all be negative. Also notice that I do these factors in order. I start with 1 in the number, and then if 2 goes into that number, I do 2 in the number next, and 3, and so on. If you list them in order like that, it's a better way to keep track of all the possibilities so that you don't skip any possible pairs of factors. So then we look at the sums on the right side of the table. So if we add 1 plus negative 12, we get negative 11, and that's not the negative 5 sum that we're looking for. If we add the 2 and the negative 6, we get negative 4. That's also not the sum I'm looking for. And 3 plus negative 4 is negative 1, and that's not equal to the negative 5 I'm looking for. But notice that I've tried out every possible pair of factors, because if I go to 4 next in my list, then 3 is the other factor, and I've already used the 3 and the 4. So I know that I've tried every possibility, but I did not get the sum I need. So when that happens, when we do not find the sum we need and we've tried every possible pair of factors, then this tells us that the trinomial is prime. So that means that this trinomial does not factor. There's no way to multiply any two binomials together and have it FOIL out to give us x squared minus 5x minus 12. So we say that this trinomial is prime. Here's an example of where we need to factor completely. So you'll hear me say this a lot, that the first step you need is to find the greatest common factor. So notice that this trinomial, all of the coefficients are multiples of 3. So I have a GCF of 3 that I can factor out. So I factor out the 3 and notice that I have a trinomial left, x squared plus 3x minus 28, and it's possible that this polynomial that's remaining might factor itself. So if that factors further, we need to keep going in order to factor completely. So since this is a trinomial, and notice the first term is x squared, so the leading coefficient is 1, then I go ahead and write 2 sets of parentheses and place my x's in front. And then I'd be looking for 2 numbers that multiply to give me my constant, so that would be negative 28. And they would need to add to give me the positive 3, which is the middle coefficient. So if you make your table of all possible factors of negative 28, you'll see that the 2 numbers that add up to positive 3 would be negative 4 and positive 7. So we place those in the parentheses with the x's, and notice that the 3 that we pulled out in the beginning just stays out front in each step after that, and it doesn't have any effect on what the rest of the factors are going to be. Just make sure you don't leave off the GCF on your answer. So that's it for today. Have fun factoring.